Welcome to Physics 2211 Lab 4 Oscillations by Blake Schwabe. The purpose of this lab is for testing the oscillations of mass on a spring between the model and a real-life application of the oscillation in the experiment. Learning more about the movement of a spring beyond one axis of movement that we have learned thus far. The principles used were Newton's second law, force equals mass times acceleration, and the energy principle, meaning energy cannot be created nor destroyed, it can only be transferred. And using the tracking and coding information that we have learned from previous experiments, we can see that there will be a slight differences between the observed versus the modeled, but we will be given the same idea about that topic. The system is the spring itself, the mass of the object, and Earth for gravity's sake, and the surroundings are none for this experiment. In the experiment, we were given a video as a baseline for the experiment, and we used its measurements given. Mass was calculated to be 0.402 kilograms. Ks was measured to be 6.83, and L naught being 1.23 meters. I used the 0.7 meters for the calibration of the video. When using point mass, the initial point that I calculated was negative 0.113, negative 0.66, and 0. I plugged in the values for the given experiment to the code as the values for the experiment to keep the model and observation as equal as possible. The equations I used: velocity update, position update, gravitational force, kinetic energy, spring force, gravitational potential energy, and spring potential energy were the main ones. Code part 1. I just edited the code a little bit so it gives the right information. The code in the predicted modes, L, L hat, and S, and the energies were given in the standard formulas. You can see the mass, the position was changed, the delta T was kept the same, gravity was still at 9.8, Ks was changed, and then L naught was changed, and then the L, L hat, and S were given their respective formulas. For part 2, we added the code so that it gives us the forces and energy changes the right formulas for it to work properly. You can see that with K, UG, US, and E mainly. Then you get the force of gravity, spring force, net force, the velocity, position, a repetition of L, hat, and S. And then afterwards, you would actually see the rate. I actually upped it a little bit, so it's a little bit faster for me because I had a lot of data to go through. And I changed it to about 9.41 because that was the amount of time between the session. And here are the results. The graphs are very similar, but the smooth model one was fine, but it was very choppy for the experiment, especially in the x position versus time graph right here. The problem was I did 3 times, and this was the best one I could get, the closest I could have. Y was a little bit better, and the energy was spot on. Discussion. The changes between the x and y graphs were about the same for the model as with the observed, besides a few caveats that I've already mentioned. With the model being smoothed out while the observed one was more choppy. The energies were all plotted in the previous model, and that when the energies were combined, the orange line that you can see were all equal. So you could not create nor destroy, it just transfers the energy. The errors that could happen, this human error getting the data, you saw from the x-axis, error in the coding, error with the tracking of the object, as you saw again with x position right here, and then error in putting in my formatted data. I fixed this a little bit, but there still could have been an error somewhere. The conclusion, what does this mean? Well, in part 1, all energy satisfied? It is actually from the energy principle because delta E, or the change in energy, was 0 the entire time. That means all the energy stayed the same. There was no addition or subtraction of energy within that system. For part 2, for estimations of periods of oscillation, since we had the graphs and the data, we were able to actually calculate it for ourselves, and we got a period of about 1.519 for the x, and for the y, we got about 1.614 for period oscillation of y. And the differences that I could see, it could be gravity slowing down the period oscillation for y, meaning that x would actually have a lower time per oscillation. That's why there's a slight difference. And that is all. Thank you for watching.